In this video, we are going to look at complex numbers. We'll look at sort of what a definition, maybe why we use them, and we'll also look at doing operations with complex numbers. So to begin with, just in a discussion a little bit on number systems, in your math experiences, you've probably looked at lots of different number systems. You would have started with the counting numbers, the natural numbers, and then moved up to whole numbers where you have a zero in. And you do operations with all of these. So you'd add or subtract these, you'd add or subtract, multiply with those. Then you'd move into positive and negative numbers, and those are called integers. Then you start looking at numbers in between the -1 and -2, or you look at things like rational numbers, which are fractions or decimals. Sometimes special decimals are ones that never repeat, and those are called irrational numbers. And irrational numbers, like square root of 17 would be an example. Pi is another example of an irrational number. The number e, another example of an irrational number. They're numbers that have decimals that never start repeating. Like if you divided 1 by 4, you get 0.25 and it stops there. Or in other words, it has a zero that repeats on forever. Or if you take 1 divided by 3, you get 0.33, and we say repeating. In other words, it repeats forever. Irrationals are ones that repeat, or that never repeat. They still go on forever, but they don't start repeating. So those are irrational numbers. Together, all of these number systems are called the real numbers. Now, when you look at the square root of 17, that's a square root of a natural number, but you could also take the square root of a negative number. And if you take the square root of a negative number, those are numbers that we call imaginary. Some people call them fake numbers. Proper name is imaginary numbers. On the next slide, I'll show you one reason why we have those. Together, imaginary numbers and real numbers are called the complex numbers. And so we're going to do similar to what you've done with every one of these other number systems, is we'll learn how to add, subtract, multiply, and divide them. Here's just one reason, definition of complex numbers. They're numbers that can be written in this form, where A and B are real numbers, and then you have an I there. And an I is a representation, or it indicates that you have an imaginary number. So here's an example of an imaginary number. Here's another example of an imaginary number. We've played with 4s, played with 3s, played with square roots, but probably you haven't done a whole lot with an I attached to that. But the I there indicates that you have a complex number. Okay, so here's where you could see why we might need complex numbers. If I'm looking for the zeros of this quadratic function, I can use this quadratic formula to help me find them. I'm not going to do it, but suffice to say that when you do this quadratic formula, the answers to that will come out to this number there and that number there. Now, sometimes when you do the quadratic formula on a function, you wind up with some numbers, but you also come up with a square root of a negative number in here. It doesn't matter what the number is as long as it's negative. If it's negative, that indicates to me that the reals or the solutions, the zeros for that function, do not cross this x-axis. In other words, you have a parabola that looks like that. It's still quadratic functions. And it's a useful shape, useful thing that we could use, but it doesn't cross this axis. And so we say the zeros for that function are imaginary. Okay, and we know that because there's a negative number underneath the square root sign. So since we see that once in a while, we want to be able to do operations with those kinds of numbers. So first couple things to know about complex numbers is that whenever you find the square root of a -1, you can make that equal to an I. So typically we don't want to see the square root of a -1. We'll always want to convert that to an I. Another thing that happens, okay, so if I ever see the square root of -1, call it an I. Another thing that happens is one thing that you can do with these, with square roots, often to get rid of them, you can square them. So if I square that side, on this side, I'll be left with a -1. On this side, if I square it, I'll be left with an I squared. So here's another thing that you can use. So whenever you see a square root of -1, change it to an I. Whenever you see an I squared, you can change that to a -1. Okay, so we'll be doing quite a bit of that as we go through the operations. Square root of -1, call it an I. If you see an I squared ever, you can make it equal to a -1. Okay, so let's work on a couple of simplifying numbers, like this one here, square root of -16. If I wanted to simplify that, I could rewrite that according to radical rules as -1 times 16, right? I'm just breaking -16 into the product of two numbers. According to radical rules, I can rewrite that as the square root of -1 times the square root of 16 and multiply those two. Now, just from the last side, we said every time you see a square root of -1, you can make that an I. So this thing here, I can make an I, and the square root of 16, I can call 4. So, and that's multiplied, so the square root of -16 is actually 4I. Here's another one, square root of -20. Again, I can change that to the square root of -1 times the square root of 20. So I can call that an I and the square root of 20. Now 20 I could probably simplify just with radical rules again, that's the same thing as the square root of 5 times square root of 4 times the square root of 5. Square root of 4 is 2, and I have a root 5. And then just to reorder that, usually we'd write it as 2 root 5, and then we put the I at the end. Notice that I'm putting the I outside of this radical here. Don't extend that over there, because that would be incorrect. You want to keep the I outside of the radical. Now let's do some adding and subtracting. So first rule, first thing to keep in mind, if you're doing any converting radicals, or if you're doing any operations, make sure you convert any radicals to the I form first. In this first question, they're already in I form, so I don't need to do anything. Then it says the I part of any complex number, you can treat it like any other variable, like an x. So if I'm adding these two expressions, because I'm adding, I can drop the brackets and just rewrite them. And then I can collect like terms. The 7 and 8 are alike, so I'll call that 15. And the 7i and minus 2i are alike, so I can collect those. 7 minus 2 would be a plus 5i. And that's the way I would write the answer. Some people say, well, you could factor a 5 out. And that's true. That would be another way of expressing it. But typically, whenever we're writing a complex number, we want to write it in the form a plus bi. And so they're both the same, but this first one is the proper way to do it. Okay, this next example, first I have to get rid of the square root of a negative. So I'm going to change this first one. Square root of 49 is the same as square root of -1 times the square root of 49. So this would be 7i, because the square root of 49 is 7. And the square root of -1 is an I. Okay, minus 8 minus, this one will be 6i. Now, since it's subtract, I need to apply that subtraction to both terms in the second bracket. So I'll drop the first bracket, and then I'll have minus 8 and a plus 6i. Now we'll collect like terms. 6 take away 8 is a -2. 7 plus 6 is a plus 13i. So that would be my answer to that question. Okay, so it's subtracting complex numbers. Here's a couple questions. Why don't you pause the video, try them on your own, and then come back and see if you've done them right. Okay, hopefully you've pressed play again. So if I was doing this one, I would write 2 plus 5i minus 8 plus 3i. And then I'd collect like terms. Minus 6 plus 8i. That's what you should have got there. For this one might be a little bit tougher. 3 plus Square root of negative 20 will be, I could call it root 20i, but I might be able to simplify that. Plus 5 minus, this will be the same as the square root of 45i. These ones didn't come out even, but I wonder if I'll be able to collect them. Currently I can't, but let's see if I can simplify it. Root 20 is 4 times 5, right? So square root of 4 is 2, so I could write this as 2 root 5i plus 5 minus 45 is 9 times 5, so this is the same as 3 root 5i. Now I've got terms where they're alike, I can collect them. So 3 plus 5 is 8, and then 2 root 5i minus 3 root 5i would be a minus 1 root 5i. And probably you wouldn't write the 1 in front, you just call it like that. Okay, so that's adding, subtract complex numbers. Let's look at multiplying complex numbers. Like I said in an earlier screen, knowing that I squared is equal to negative 1 is useful. So, and again with this operation, like adding and subtracting, you want to make sure you convert any negative radicands, get them in the I form first. So here I've got a negative radicand, I'm going to call that 2i. And then square root of negative 12, I can call that root 12i. Root 12, again, that's 4 times 3. I'm always wanting to simplify those radicals. So I'll have 2i at the first, and then this will be, square root of 4 would be 2, so this would be 2 root 3i. Well, I should have put the I in there. Okay, so now I can multiply. So 2 times 2 root 3 would be a 4 root 3. I times I would be I squared. Then, anytime I see an I squared, I can replace that with a negative 1. So this would be 4 root 3 times a negative 1. And typically, we would write the negative at the first. So we'd write it as negative 4 root 3. So that would be the product of that. Notice at the first here that this is one of the rules that doesn't work for radicals. Typically, if you're multiplying radicals, you can just multiply the 4 by the 12 and call it good. But because they're complex numbers, this rule doesn't work. And notice that the answer, if you go minus 4 times minus 12 is 48, that this answer and this answer aren't the same. This actually does simplify to 4 root 3, but it's a positive, whereas our correct answer is a negative. So that's why we say convert any negative radicands first to an I form and then multiply. Okay, here's some more multiplying. And it's just some practice. Again, if you want to press pause and give them a shot on your own, and then come back and take a look. Okay, so for this first one, I would call this root 5i times root 8i. And then the root 8 I can simplify. I guess I could multiply those together. So root 5 times root 8 would be root 40i. And this 40 is the same thing as 4 times 10. So I could write that as square root of 4 is 2, so it'd be 2 root 10i. This next one would be distributive property. So 3, maybe I should get rid of that negative radicand first. Let's go root 5 times 3 minus, that would be 6i. Okay, now I can use the distributive property. So root 5 times 3 is 3 root 5 minus root 5 times 6i would be 6 root 5i. Okay, good. Next one, it's a FOIL kind of thing. But let's first convert it to the I form. So it'll be 3 plus 5i, and then 5 plus 4i. Now I can use the FOIL thing. So 3 times 5 would be 15. 3 times 4i would be a plus 12i, plus 25i, plus 20i squared. Okay, I can combine these middle two. So 15 plus, that'd be 37i plus, and anytime I see an I squared, I can make that a negative 1, right? So that would change this sign. Let me me get rid of that sign. So this would become a negative 20. Oh, and then I've got like terms again. 15 take away 20 would be a negative 5 plus 37i. That'd be my answer for that one. Okay, so that is multiplication. Now we can also divide. When you're dividing complex numbers, similar to having when you're using radicals, that you don't want to have a radical on the bottom of a fraction. Typically, I have to fix that. Same thing with complex numbers. I don't want to have an I in the denominator. So the way I get rid of that is by multiplying by something by a factor of 1. In other words, multiply the same thing on top and bottom so that I get rid of the I. Easy way of getting rid of an I is just multiplying it by an I, because I times I is going to be I squared, which, right, is a negative 1. So if I multiply the bottom by I, I'll multiply the top by an I. So I'll get 5i over 3 times I would be I squared. And like we said, and you could think about, oh, maybe I could cancel the i's here, but you don't want to do that because I squared, you want to make that into a negative 1. So it's negative 1 times 3, which would be negative 3. Now I've got an expression where there's no i's in the bottom. That's good. Here's another one at the bottom. This one may be a little bit tougher because there's a radical in there too. So I can rewrite this as 5 over root 12i. And if I want to get rid of the I, I'm going to multiply the top by an I and the bottom by an I. So I'll get 5i over root 12i squared. And I squared is a negative 1, so this would be a negative root 12. Notice the negatives outside the radical, that's okay. But on the bottom, I don't want to have an I, but I also don't want to have a square root. So I want to multiply this by something so that I get rid of the square root on the bottom. So you multiply it by a number so that you get one of those perfect numbers. The perfect numbers being perfect squares of 2, 3, 4, 5, 6, 7, etc. And it turns out I can multiply 12 by 3, and that would give me 36. So if I multiply bottom by 3, I got to multiply the top by 3. So the top, I'm going to have 5 root 3i over negative square root of 36. So on the top, 5 root 3i over negative the square root of 36 is 6. So there, that was a tough one. I had to get rid of the I, did that, and I also had to get rid of the square root. So we did that. Here's some questions you can on your own and see if you can get rid of the I on the bottom. Press pause, then press play. So here I would multiply top and bottom by I. So I get 12i over 5i squared, or 12i over negative 5. Done. I guess you could rewrite that as negative 12i over 5. Typically, we like to put the negative on the top instead of the bottom, but this is still correct. Even putting the negative in the middle is correct too. Okay, for this bottom one, first I would change this to an I form. So it'd be 3 over 8i, and then I'll have to multiply top and bottom by I. So 3i over 8i squared, or 3i over negative 8. Okay, now you can have i's in the bottom on their own or as just a single factor, but you can also have i's as part of a binomial or two terms. And you can't just multiply this by an I because you won't get rid of the i's on the bottom. So the trick that you do is you multiply it by the conjugate. And by the conjugate, I mean that you multiply it by the same binomial, but you change the middle sign. So instead of 3 minus I, you change that to 3 plus I. And if you do that on the bottom, you have to do that on the top as well. Okay, so on the top, I'll maybe just leave that as 12 times 3 plus I. And then on the bottom, this is where I'm going to have to FOIL that whole thing out. So it'll be 9 plus 3i minus 3i. See what's going to happen to your i's there? Minus I squared. So on the top, I'll have 12 times 3 plus I. On the bottom, it'll be 9 minus, I squared is a negative 1. So 9 minus a negative 1 will actually be 10. So it'll be 12 times 3 plus I over 10. And then I can simplify the 12 and the 10 just as a final thing. I can divide 2 into both of those. So that'll be 6 times 3 plus I all over 5. Okay, here's another one. Maybe press pause and then press play once you figure this one out. Okay, multiplying this one, the conjugate of this one will be the same thing, the minus 3 and the I, but I just changed that middle sign. Okay, so minus 3 minus I. Okay, so on the top, 2 times minus 3 is minus 6. 2 times minus I is a minus I. Minus I times a negative 3 is a plus 3I. Minus I times a minus I is a plus I squared. Okay, over. On the bottom, minus 3 times minus 3, so it's 9. Be plus 3I minus 3I minus I squared. Okay, so on the top there, minus 6, minus I plus 3I be a plus 2I, and then plus I squared is a negative 1, so it'd be a minus 1. All over 9, these two cancel. I squared is a negative 1, so it's minus a negative 1, so that'll be plus 1. So on the top, minus 6 minus 1 will be a minus 7 plus 2I, all over 9 plus 1 is 10. Now you can leave your answer like that, but remember at the start we said we want to write these as A plus BI, and so you could change that to just apply the 10 to both numerators. So it'd be minus 7 over 10 plus 2I over 10. Oh, and this 2I you could simplify. So it'd be minus 7 over 10 plus I over 5. That's probably the answer you'd see in the book. If you get to this point here, I'm very happy. But this is just finishing things off. Okay, let's talk about in this section is looking at powers of I. And this is just maybe just a little exercise in looking at factors and seeing if you can simplify things. If I know that I squared is equal to negative 1, then what I can do, if I have a higher power I, like I15, I can break that down into factors. So I could say, well, that's the same as I squared times I squared times I squared. How many do I have to do? That's 8, 10, 12, 14, 15. There. So I15 is the same thing as this. But each of those I squareds is negative 1, right? This is going to take me a while to do. And then an I. Then I can say, well, negative 1 times negative 1 is a positive 1. Positive 1. Positive 1. And that one I'm stuck with. So my answer to the end of this, if I multiply 1 times 1 times 1 times a negative 1 times I, I'm going to wind up with a negative 1I, or negative I. Now, if you get a number like an I33, that makes it a little bit tougher and longer to do. But so what you can do is just say, well, I can look at not just an I squared, but how about if I have an I to the 4th? So I squared times I squared is I to the 4th. And anytime I have an I to the 4th, that's equal to 1. Or I could even go further than that. How about we take a look at those right there? So that would be how many i's? That'd be I to the 8th. So if I have I to the 8th, that's the same as this stuff down there, or 1 times 1. I to the 8th is also equal to a positive 1. And I to the 4th is equal to a positive 1. So if I have a question like, say, I to the 9th, what's I to the 9th? Well, I could say that's the same as I to the 8th times I. And I know I to the 8th from here is equal to 1. And so my answer is 1 times I, or just I. Similarly, like if I have an I33, maybe try that on your own. Press pause and then try it, and then press play. Okay, so if I have I33, I would say that's the same as I to the 8th, and I'd actually have 4 of those, right? because 8 times 4 is 32. So there'd be 4 of those, plus I'd have another I. So that altogether is I33, but I know that I to the 8th is 1, and 1 to the 4th is just going to be, whoops, I to the 4th, I. I to the 4th is just 1, and 1 times I is just I. So I to the 33 is just I. Now I've done a couple questions where they both came out I's, but let me maybe try a different one. Let's say I to the 63. Okay, so if I do I to the 63, I could say, well, that's I to the 8th. How many of those would I have? I wouldn't have 8. I could have 7. That'd be 56, right? And then I'd need an I to the 4th on that. That'd be 60. And then an I squared. That'd be 62. And an I. Okay, so I to the 8th is 1. And 1 to the 7th is going to be 1. I to the 4th is also 1. I squared is a negative 1. And then I have an I. So, there should be a times here, sorry. So 1 to the 7th is 1 times 1. So this one is just going to wind up in the end to be a negative I. All right, so when you do these questions, all of your answers, you're going to come up with one of those 4 things. All the ones I came up with had I's in them, but you could get an answer where it's a negative 1 or a 1. All right, that should give you enough tools to help with your homework. Try it. If you have questions, as always, give me a holler.